Chapter 1, Sample Problem 1.4 is another conversion problem. This time we're going to be converting units of volume. So the problem says, the volume of an irregularly shaped solid can be determined from the volume of water it displaces. A graduated cylinder contains 19.9 milliliters of water. When a small piece of galena, an ore of lead, is added, the volume increases to 24.5 milliliters. What is the volume of the piece of galena in cubic centimeters and in liters? Okay, so this is going to be another problem where I like to use my T. And so it's given us information. The first step is to kind of note or write down everything that it's given us. And so it's given us these numbers, this 19.9 and this 24.5 in units of milliliters. So I'm going to have to figure out what the actual volume of the piece of galena is. So to do that, the first step is going to be to subtract. So after they put the piece in, the volume was 24.5 milliliters, and it started out as 19.9 milliliters. So if I just do the difference between those, that's going to tell me the volume of the piece, and that's going to be 4.6 milliliters. Now we're ready to convert that into these units that they're asking about here. So I'm going to have to use table 1.3 and 1.4 again to figure these conversions, to convert these units to the units that they're asking for. So I'm going to start out my T with 4.6 milliliters. You always start the top left corner of the T with what you're looking for. Now, if milliliters is in the top of my T, it also has to be in the bottom so that it can cancel out, so that I can eventually be left with the volume the problem is asking. So I'm going to go ahead and put milliliters in the bottom right there, and I flip into my textbook, let's see, what page? To page 14, and I look at these conversion factors for volume that I have here. And I see that in 1 milliliter, there is 1 cubic centimeter. Okay, so now let's do I like to always, so what's that going to equal? I like to always do my units first, right? And so remember, everything in the top of the T gets multiplied, divided by everything in the bottom of the T. So let's see, I have milliliters divided by milliliters, which equals 1, because anything divided by itself equals 1. And then I have cubic centimeters, and that's the only unit that I have left here, and that's one of the units the problem's wanted me to solve for. So let me go ahead and write that down, cubic centimeters. Now I can look at the numbers and do the math. So I'm going to have 4.6 times 1 divided by 1, which is equal to 4.6 cubic centimeters. Now we have to do the same thing for liters this time. So we're going to have to set up another T. Let me put a box around this one. That's our first answer. So I've got 4.6 milliliters, and I need to convert that to liters. And notice the thing here, this is a prefix conversion. The base unit for both of these measurements that we're looking at here is the liter. Right, I've just got milliliters, and then I have and then I'm wanting to convert to liters. So let me go ahead and put milliliters in the bottom of my T, because if I have it in the top, I need it in the bottom so that it'll cancel out, and I can be just left with the liters that I'm looking for. So I look at this prefix on table 1.3 of milli, and it says it's 1,000th, which means that there are 1,000 milliliters in 1 liter. Okay, so now let's check my units to see if I'm going to be left with what I'm looking for. I have milliliters in the top of my T divided by milliliters in the bottom of my T. Milliliters divided by milliliters is going to equal 1. They're going to cancel. I'm going to be left in units of liters. So let me go ahead and write that over here. And now I can do my math. So I'm going to have 4.6 times 1 divided by 1,000, and that's going to be 0.046 liters. Let me put a box around that.